our next speaker is Campbell, Tech Observatory. We all know him for all of the support he's given us over the years with all of the instruments at Tech. And he's talking about exciting Isoris X7, Galactic 7.
Thank you, Shelley. It's a pleasure to be here, and I want to thank the organizers for giving me this talk. I also want to mention my co-authors. This is some work I've been doing with the Galactic Center group at UCLA, and in particular, Anna Chirlo and Mark Morris over the last few years. Anna was a visiting scholar at Keck a few years ago, and we got started on this study of some of the interstellar medium in the very central sections near the black hole. And it's led to some interesting results. And in particular, this object X7 we find very interesting. It's a gassy, dusty filament about half an arc second right now from Sagittarius star. And in this three-color image, it's highlighted in red because it's only detected in LPrime in the thermal IR in imaging. And you can see it in the context of some of the other dust and gas features in this region. This is a beautiful image provided by Tuan Do from 2019 when Sagittarius star happened to be flaring, and is highlighted there. So that's also interesting. It's unusual for Sagittarius star to be very active at all, and it's one of the reasons we're interested in studying some of this region, is to try and understand the activity or the lack of the activity of the black hole as a galactic nucleus. Some more LPrime data from NERC2 shown in this slide as a series of panels ranging as a function of time from 2002 to 2021. Fresh off the presses from this summer. And as you can see in these 1 arc second cutout images, the proper motion and changes in shape, we're seeing, see if I can use a pointer. We're seeing it lengthen out over time, and we're also starting to see some evidence of it starting to break up a little bit. Sagittarius star is positioned in the upper left in each of these panels, and this is just LPrime at this point. Another way to maybe visualize this is with an animation, if this will play, and really see the proper motion moving as it moves about half an arc second to the north, and it's stretching out. And the tip of it seems to be moving more toward the east, and the object seems to be breaking up a little bit in this thermal IR dust emission set of data. We also are studying this object with Osiris, and we see it in gas emission features, and in particular, bracket gamma emission. Now, bracket gamma emission has very complex structure in this region near the black hole, and X7 is the high blue shifted object here. And we've been studying several of these objects that have high proper motion and accelerations. And those compact objects we think are a class of objects that include the G objects. And that work was published by Anna Chirlo just last year in 2020. But X7 is unique in that it's very extended and a little higher blue shift. And so we didn't think it quite fit into this class of objects. And so we're now focusing our study on just X7 right now. This is a three-dimensional volume display of an Isoris data cube. Has the stellar continuous subtracted to highlight just the bracket gamma emission. And you can see some residuals of the stellar continuum, but this is a nice way to see some of the bracket gamma kinematics and to highlight some of the things that we're trying to study. This is a KN3 filter with a 35 milli-arc second scale lenslet from Osiris. So from the Cyrus data, you can form images, and the grayscale images are of X7 intensity bracket gamma emission. And I've cut out just the blue shifted portion of this bracket gamma so that X7 is isolated in wavelength space. And these proceed from 2006 to 2021, the most recent. And again, we're seeing the proper motion. And these are 1 arcsecond square images, similar to the NERC2 images. And Sag star is in the upper left again. And is the same as in NERC2, we're seeing proper motion to the north, significant proper motion. We're also seeing some changes in morphology. So the bracket gamma traces the L prime very well. The color-coded images are radial velocity maps of the same wavelength space. And the contours are the intensity images overlaid on the radial velocity maps to show the primary linear filament of X7. And in radial velocity space, it's changing a lot, especially the tip. What we define as the tip is going from around minus 750 kilometers per second to around minus 500 kilometers per second in the most recent data. So the tip is decelerating considerably over this time frame. We use the proper motion measurements shown in this graph in the upper right from both NERC2 and Osiris. They agree pretty well. They're not exact to within our error measurements, but maybe either due to a systematic difference in the measurements, or possibly there's a physical difference between the dust emission and the gas emission. Not quite sure there. We also have used the radial velocity data to fit an orbit to the tip of X7. And that orbit is projected on this Osiris image here, showing it moving to the north towards Sag star. And in this projection, it's coming out of the page and will make closest approach in 15 to 30 years and at a distance of about 3,000 AU. So we're anxious to keep an eye on that. I may have to delay my retirement plans in order to keep studying this, but we'll see. Okay. So, oops. Big delay in the advancement here. So another measurement we can make is the position angle of the linear filament. And that position angle remains constant over this time frame that we're studying it. And that's somewhat interesting because if the position angle were due to wind from Sag star or from a bright star, some of the Wolf-Rayet radiation sources in this region, we'd expect a significant change in the angle as it moves this much on the sky, on the order of 30 degrees or so. And it's definitely not moving by that much. So we can kind of eliminate Sag star as a source of wind. This object was originally suggested to be a bow-shocked object that was causing the tail shape of it. But we don't think that is what's going on here. And this position angle measurement helps us exclude some of the possible explanations for it. We also compare it to the proper motion of X7 to some of the stars that happen to be in the same region. And because it's been suggested in the literature, most recently by Feisker 2021, that one of the stars is the source of X7, the SO30. In this plot, I'm showing the proper motion of X7 relative to Sag star as circles progressing from dark blue to light yellow, and the stars in that same region that are and their proper motion, and as triangles. And we don't see a strong association between any of the stars and X7. In fact, X7 is is fairly large extent and is moving over a very crowded region. So you'd expect some random association with some of these stars, and that's all we think is going on, and that we don't think that the stars explain are a source of X7 necessarily. Okay, waiting for the so to conclude, you know, we see a lot of interesting kinematics in both the Osiris and NERC2 data and dust and gas emission. You know, it's not detected in K-band other than the emission features. We think that it's very possibly due to it is experiencing some tidal forces and being stretched and starting to be torn apart a little bit by the tidal forces. We've looked at some other things like magnetic fields in the literature and some other sources of wind and jets and things like that, but we don't have any real good explanation for what is the source of this object and what may be shaping it necessarily, other than the tidal forces. And if you have some ideas on where it might have come from, please join the Slack channel and maybe we can continue the conversation then. So thank you very much. The question was what programs at Keck. So I mentioned the visiting scholar program. So when Anna Tirlo from UCLA visited Keck for a few years ago, we got started on this project and it included the G object paper, and now we're doing this. And we also get some funding through what's called the Science Collaborative Funds, and that has enabled a lot of the research that happens within the halls of Keck. And many of the staff astronomers benefit from that funding. So thanks for that question. Yes, Evan. I'm sorry, I couldn't quite hear it.
Is there any association with X7 and the young stellar population at the Galactic Center?
Well, possibly. I mean, a lot of the observables are similar to the G objects, and one of the possible explanations for the G objects is that they are binary mergers in some state of encapsulated in this dust and gas, and it could be that X7 is it in just a different state where there's still a lot of circumbinary material that's very extended, and so it could be similar to that. And after these binary mergers, after the dust and gas clears, you may have a young star on your hands, you know, an algal type thing. So that's one scenario that people have been playing around with.
Jill, do you have any questions online? Okay, let's thank Randy and we'll take questions.